A very good morning to all of you. Today we are going to discuss about chapter 11. Chapter 11, Force and Pressure. Okay children? First, we should know about what is force. Force is a push or a pull. So children, I will give you some examples by which you can understand what is force. When an athlete wants to throw a very heavy ball during shot put contest so that it may go as far as possible, he has to push the ball hard. We say that the athlete applies a large force to the ball to make it move through a large distance. When a person wants to draw water from a well, he has to pull the rope attached to the bucket full of water. We again say that the person applies a force to the rope attached to the bucket of water to make it move and come out of the well. And if by chance the sharp heel of a woman's shoes falls on our foot, it hurts our foot too much and produces a lot of pain. Why? We say that the force of women's weight produces a large pressure on our foot because all her weight falls on a small area of the pencil heel, and that falls on our foot and causes a lot of pain. On the other hand, if the broad heels of a man's shoes falls on our foot, it hurts our foot much less. Why? This is because due to broad heels, the force of a man's weight falls on a large area of our foot, due to which the pressure produced on our foot is much less. So children, when we want to open a door, what we have to do? We have to push the door handle with our hand. And when we want to close the door, we have to pull the door handle with our hand. This means that to move an object, it has either to be pushed or pulled. So a push or a pull is called what? Force. The direction in which the object is pushed or pulled is called direction of force. What is direction of force? The direction in which force is applied. An object is either pulled or pushed is called what? Direction of force. Force are used in our everyday actions like pushing, pulling, lifting, stretching, twisting and pressing. For example, a force is used when we push a football, a force is used when we pull a door, a force is used when we stretch a rubber band, a force is used when we twist a wet cloth to squeeze out water. The fallen leaves of trees fly away with wind because the force of wind pushes them away. Even sometimes roofs of huts fly away during a storm because the force of strong winds pushes them away. Before we go further, we should know the meaning of term interaction. Interaction means reciprocal action. What is the meaning of interaction? Means reciprocal action. Reciprocal action. Interaction involves how many objects? Two objects. In interaction, what happens? Each object acts in such a way as to have an effect on other object. For example, children, force is actually due to what? Interaction. Force is due to interaction. What is the meaning of interaction? That is the reciprocal action. Means two objects are there and forces come into play when two objects interact with each other. Suppose, for example, a car is standing and a man is there which is standing behind the car. So, what do you think? Will car start moving? Of course, two objects are there, but there is no interaction between the two objects. If now the man, what man will do? Suppose a man pushes the car with the hands due to which the car starts moving. When the man pushes the car, there is an interaction between the man and the car. During this interaction, a force arises which acts on the car and makes it move in the direction of applied force. So children, two objects, two things which are interacting for the force to come into play and show its effects are the car and the man. Suppose children, if both the objects are capable to applying force on each other, then the interaction between them can be pushing or pulling. For example, the two boys you can see into your book are interacting and applying force on each other by pushing each other. On the other hand, man and cow interacting, but they are applying force on each other by pulling each other. Now, force has magnitude as well as direction. An adult man can apply large force on an object, whereas a child can apply only a small force on an object. This means that a force can be larger or smaller than the other force. What we are discussing, children? Magnitude, that is the amount of force. Force can be larger as well as smaller. So, the strength of a force is expressed by its magnitude. Strength of a force is expressed by its magnitude. Okay, children? So now the magnitude of a force is expressed in the SI unit of force, which is called Newton. The magnitude of force is expressed the magnitude of a force, clear, is expressed in the SI unit of force. SI unit of force, which is called what? Newton. What does it call? It is called Newton. Or abbreviation we can write what? N. N for Newton. 1 Newton is the force which can make an object of 1 kilogram mass to move at a speed of 1 meter per second. What is 1 Newton? 1 Newton is the force which can make an object of mass of 1 kilogram mass to move at a speed of 1 meter per second. 1 meter per second. So 1 Newton is a force which is capable of moving an object of 1 kilogram mass at a speed of 1 meter per second. Along with the magnitude of force, the direction in which a force acts is also to be specified. This is because if the magnitude or direction of the applied force changes, the effect produced by a force also changes. I will repeat, children. If the magnitude, that is the strength or the amount or direction of applied force changes, the effect produced by a force is also changes. When two forces act on an object, the two cases will be arises either the forces act in the same direction or the forces act in opposite direction. If the two forces applied to an object, you can see into your book, children. If the two forces applied to an object act in the same direction, then the resulting force acting on the object is equal to the sum of the two forces. If the two forces, you can look into your book, two men pushing a heavy box in the same direction and making it move easily. So what would be the resulting force? The resulting force acting on an object, that is the heavy box, is equal to the sum of the two forces. When two forces act in the same direction, their effective magnitude increases because the two forces are acting in the same direction. This will become clear from the following example. Suppose there is a heavy box which one man can move only by applying. It is very hard. Now if two men push this heavy box in the same direction, it becomes much easier to move the heavy box. This is because when the two men apply their forces to push together in the same direction, the two forces add up. What would happen? The two forces which are applied by the two different persons add up and to provide a much bigger force, much larger force, and this bigger force can move the heavy box very easily. Now suppose there is a heavy box lying on the ground and the two men push this box from opposite direction, one from the left hand side and other from the right hand side, assuming that one of the man is stronger of the two and applies a larger pushing force than the other man. We can say that the box will move in that direction in which the larger force is applied by the stronger man. Now the two mans are there and they are pushing the box, one from left hand side, one from right hand side. So box will move in which direction? It will move in the direction where the force will be larger, or we can say the man who will apply the larger force, the box will move in that direction. The box will, however, move very slowly in this case because the net force or the resulting force which is acting on the box in this case is equal to the difference in the magnitude of the two forces applied by the two men. If the two forces applied to an object are equal, so three conditions this is the third condition, children. One condition in which we saw that the two men, they are pushing that heavy box in the same direction, so the magnitude of the force will be larger. In the second direction, we have seen that the two forces are acting, of course, but they are acting in the opposite direction. So the resulting force acting on an object will be equal to the difference between the two forces. If the two forces applied to an object are equal in magnitude and act in opposite direction, then the net force acting on the object is 0 or nil. Since the net force acting on the object is 0, in this case, the object does not move at all. For example, if the two men push a heavy box from opposite direction by applying exactly equal forces, then the heavy box will not move at all. It will remain where it is. A familiar example of this case of equal forces acting in opposite direction provided by the game called tug of war, children. In this game, two teams of persons pull at a rope in opposite directions. Members of both the teams try to pull rope in their direction. When the two teams pull the rope equally hard by applying equal amount of forces, the rope does not move in any direction. You can see into your book. At this point of time, the two teams are applying equal but opposite forces to the rope, due to which the net force acting on the rope is 0 or nil, and hence the rope does not move. Actually, the equal and opposite forces applied on the rope cancel each other's effect. Ultimately, the team which pulls the rope harder by applying greater force wins the game. That's all for today's video. We will thank you and have a nice day. Next time we will discuss about effects of force.